Hello everyone. Myself Dr. A.Victoria Anand Mary, Assistant Professor, PG and Research Department of Computer Science, St.Joseph College of Arts and Science, Autonomous Cuddalore. In this presentation, we are going to learn some of the important topics in research methods from Unit 2. The topics covered in the presentation are basic principles of experimental design and important experimental designs. That is, we are having two types of experimental design, that is informal experimental design and formal experimental design. But in this presentation we are going to cover about informal experimental design. There are three basic principles of experimental designs, that is replication, randomization and local control. And these principles are used to increase the accuracy by reducing the experimental errors. First, let's see about the principle of replication. That is, we are going to repeat the experiment more than once and we are going to measure the experimental data. Each treatment is applied to more than one experimental unit also to reduce the error. Replication is introduced in order to increase the precision of the study. That is to say that we are going to increase the accuracy with which the main effects and interaction can be established. Next, we are having the principle of randomization, where we are going to choose the sample in random manner, and we conduct an experiment against the effect of external variable, that is extraneous factor, by randomization. And the principle instructs us to design or plan the experiment in such a way that variation caused by the external factor can be combined, that is it can also be measured under the heading of chance. And when we are going to measure the external factors data, we can eliminate the error from the final outcome. That is, we can have a better estimate of the experimental error. Under this principle, the extraneous factor, that is external factor, which is going to affect our experiment is found, and it is the known source of variability, and it is made to vary deliberately over a wide range as necessary. And this needs to be done in such a way that the variability it causes can be measured and hence eliminated from the experimental error. And the experiment should be planned in such a way that we can perform a two-way analysis of variation, and in which the total variability of data is divided into three components, that is treatment, extraneous factor and experimental error. All these methods and principles are going to eliminate the experimental error from our experiment. Experimental design refers to the framework or overall structure of the experimental research, and it is classified into two major types, that is informal experimental design and formal experimental design. The informal experimental design is a less sophisticated form of analysis based on the difference in magnitudes, whereas formal experimental design offer relatively more control and use precise statistical procedure for analysis. There are three major types of informal experimental design. They are before and after without control design, after only with control design, before and after with control design. Before starting, let us get familiar with certain terms that are used with these experimental design. First one is the treatment. It is a combination of experimental conditions applied to an experimental unit. And the other one is test area. It is a block of sample where we will be introducing the treatment. And the other one is control area. It is a block of sample under study, but here we won't be giving any treatment, but we are going to observe this particular control area for our research purpose. And the first informal experimental design, as we see, is before and after without control group or control design. In such a design, a single test group or area is selected and the dependent variable is measured before the introduction of the treatment. And the treatment is then introduced and the dependent variable is measured again after the treatment has been introduced. And the effect of the treatment would be equal to the level of phenomenon after the treatment minus the level of phenomenon before the treatment. The overall design of before and after without control design is given here, where we are having a test area and we are going to measure the level of phenomenon before the treatment, which is given as X, and we are going to introduce the treatment, and we are also going to measure the level of phenomenon after the treatment, which is given as Y, and the treatment effect we can get from Y minus X. That is level of phenomenon after the treatment minus level of phenomenon before the treatment. But the main difficulty which we are going to face is, over a period of time we might have external factors which may affect our experiment, and we may have a variation in the treatment effect. And the next method is after only with control design. That is, we are going to measure the data only after the introduction of the treatment in both the areas. That is, we are going to have two groups or areas that has been selected, and the treatment is introduced only to the test area, and the dependent variable is then measured in both the areas at the same time, and the treatment impact is assessed by subtracting the values of the dependent variable in control area from its value in the test area. We know that after only with control design we are having a two areas, that is test area and the control area, and we are going to introduce the treatment only to the test area, and we are going to measure, that is the treatment effect can be measured by Y minus X, where Y is the level of phenomenon after treatment in the test area and Z is the level of phenomenon without treatment in the control area. From this we will be getting the treatment effect in this method. And the third method is before and after with control design. As the name suggests, we are going to have our measurement of the dependent variable before introduction of the treatment and after introduction of the treatment, and in this design two areas are selected, and the dependent variable is measured in both the areas for an identical period of time before introduction of the treatment, and once the treatment is introduced we are also going to measure the dependent variable after the introduction of the treatment. A treatment effect is determined by subtracting the change in the dependent variable in the control area from the change in the dependent variable in the test area. This design is superior to the previous two designs for the simple reason that it avoids external factors, variation in the treatment effect due to external factors. In this design we can see that we are having two areas that are selected, that is test area and the control area. And test area is the area where we are going to introduce the treatment, and control area we are not going to introduce the treatment, but it is the area under study. And important factor is that the level of phenomenon is measured in identical time period in both the areas. Okay, this is the important factor. And as we can see that the level of phenomenon before treatment is X in test area, and once the treatment is introduced the level of phenomenon after treatment is given as Y. In the test area we can have a measure as Y minus X, and in the control area the level of phenomenon without introducing any treatment is given as A, and in the identical time period we can also measure the level of phenomenon without treatment in a control area, that is Z, and the overall treatment effect can be given as Y minus X minus Z minus A, that is in the test area minus in the control area. From this we can get the overall treatment effect of this particular design, experimental design. Thank you.